Hey everybody, this is Mr. Nixon coming back with another video for you guys. I wanted to kind of talk about something from chapter 25. A few of you reached out to me about some questions with 25, and I am so glad that you reached out to me with those questions. It actually makes me a little nervous when people don't have questions about chapter 25, because it either means that you understand it completely or you just kind of waiting until the last minute to memorize everything and not quite understand the differences between some of the terms. And then that's when you start to freak out. And I say that because I used to be the second student, the one that waited to the last minute to memorize it all, and then started noticing that there were a lot of words that resembled one another, and I got them confused on the test, and it showed for it. So to avoid all of that, let me just tell you two major things. First and foremost, let me talk about some keywords. These words, they should be in your study guides as well. So if you haven't started on the study guide for chapter 25, here's 4 free answers for you. It's 4 words. It's intracellular, extracellular, interstitial, and intravascular. And it's funny because I'm looking at a note that I wrote about all 4 of those words. And the reason why I wrote this note is to keep me on task, because when I talk about this in lecture, I talk about it a lot. And I really hone in on it a lot in lecture so people can follow me when I'm talking, because I use these words a lot in my face-to-face lectures. The first word is intracellular, and if you took any medical terminology, these words are not difficult to you. But just in case, intracellular, intra means within. Cellular is talking about the cell, so this is referring to a fluid that's inside of the cell. So when you talk about intracellular fluid, you're talking about the fluid that's inside that cell, the organelles and everything else inside that cell are pretty much floating around, suspended in that fluid. When you start talking about extracellular, extra means outside of cellular, the cell. So extracellular fluid is referring to actually any fluid outside of the cell. And that's any fluid. So as you continue to read, you will find that there are actually categories of extracellular fluid. One such category is interstitial fluid, which you hear teachers use a lot, because interstitial fluid, it means in between. Stitial is talking about tissues. So fluid that's in between the cells or the tissues of the body. So your cells are actually surrounded by little small channels of fluids. So if you could imagine your groups of cells living on little islands separated from one another by little streams of fluid, that's one way to kind of envision it. And then you have intravascular fluid, which intra is inside of, or inner. Vascular is referring to blood vessels. So intravascular fluid is referring to the blood, and the fact that this is the fluid that's inside blood vessels. Now, why is all of this important, and why is it important to know the difference between those 4 words? Because when I'm moving things around in the body, they are moving in between these fluids. And this is a concept that people really struggle with, and they don't realize that they're weak in these terms until they get to their nursing program. And then they find out just how little they understood about these. So here's the deal. When I eat something, like I've got my lunch over here, when I eat something, that food goes into my alimentary canal, into my digestive tract, but it's not really in me yet. Like, it's in my digestive tract, which happens to be inside my body, but my cells don't have access to what I just ate. It's in a tract, it's being broken down by my digestive tract, and then it has to be absorbed from my digestive tract into some extracellular fluids. All right. If it's a carbohydrate, if it's if it's a monosaccharide like glucose, if it's some amino acids, if it's some vitamins and some minerals, those are going to get absorbed into my bloodstream. That's an extracellular fluid. To be specific, it's an intravascular fluid. So it goes into those fluids, and then it has to diffuse out of those fluids into the interstitial fluids, which is the fluid around my cells. And then it diffuses from my interstitial fluids into my intracellular fluid, which is the fluid inside of my cells. And then my cells can manipulate those nutrients. So as you can see, if I eat a Snickers bar, like if I eat some of these mixed nuts here, I'm not trying to promote this brand or anything like that. This is just a snack I just happen to have with me. Hey, it's non-GMO. What can I say? But if I decide to eat this snack, it's got some really good fatty acid contents to this snack. Um, I mean, my cells don't get a hold of those fatty acids initially. If they're larger fat contents, they're going to go into my digestive tract. Lingual lipase will start it off. Then it'll get hit up by pancreatic lipase and any brush border enzymes, my bile. They'll help to break down those fats. They'll then get absorbed into the lacteals of my lymphatic system and then dropped into my bloodstream later on. Then once they go through my bloodstream for a while, then they can be absorbed into the interstitial fluids and then into the intracellular fluids of my individual cells. These nutrients have a pathway that they have to go through, and they have to go through these fluids. That's why you have a lymphatic system that drains all those extra fluids, those extra interstitial fluids, because sometimes nutrients do all that traveling, they diffuse into the interstitial fluid and they don't go anywhere. They get stuck there. And so you need them to actually be drained and then re-added back to the blood so it can go back through that whole diffusion process all over again. So you got to be careful with these fluids. They're going to come back. You'll need to be able to understand them in your health science programs. Those of you who are not going into health science programs and you say, yo, I just needed this class to be about this piece. Peace. All right, that's cool. But for the rest of you who are going into your health sciences, you are definitely going to need to understand these fluids because you're going to have to understand them for medicinal purposes. All these pharmaceuticals you guys are going to have to learn about. Um, oh man, you're going to need to know them for a lot of different things, diseases and disorders, countless ones. So it's important to know how things go from fluid to fluid to fluid. It's just like if I'm taking the interstate and I get off the interstate onto a highway, and from a highway to a major street, and then from a major street to a side street into a neighborhood, and then to the street that the house is on, and then to the driveway, and then into the garage. Okay, I went through a process to get inside of the house. And the same thing happens when nutrients travel through fluids to get inside of a cell. So just think of it that way. The other thing I wanted to tell you about was blood pH and understanding that. I really wish that we had like this prequel class to kind of hit you off with understanding biochemistry and stuff like that before you had to take this class. I would love to talk in that class and kind of walk you guys through some of these basics. pH is one of those chemistry basics. pH basically is telling me how many specific types of ions I have in a solution, specifically hydrogen ions. If I have a whole lot of hydrogen ions in a solution, then that solution is going to be acidic. If I have very few hydrogen ions and I have more bicarbonate ions, more hydroxyl ions, then that's going to mean that that solution is basic or alkaline. One solution is not better than the other. Typically, we tend to, say, oh, acidic is bad and alkaline is good, and I'm drinking alkaline water, so I'm awesome. No offense, alkaline water is some good stuff, but you know, You have to understand why certain solutions have to be a certain pH in a certain place. For example, your blood has a pH of somewhere around the range of 7.35 to 7.45. That means it's slightly basic because a pH of 7 is neutral. So anything below 7 is acidic, anything above 7 is basic. You want to remember that a pH is very sensitive. A lot of things are very sensitive to a pH. So you can adjust the pH of something just by like 0.1 and it can show an effect depending on what it is. Your cells are like that. You start making the environment acidic around a cell and its metabolic processes will begin to slow down. And if you keep it too acidic for too long, it'll actually start to break down. You don't want a cellular environment to be too basic, because if it's too basic, it can actually affect the functionality of certain proteins, and this can become problematic. I'll give you an example: hemoglobin. So hemoglobin in the blood, if the body becomes slightly acidic, that's kind of a sign to the hemoglobin that maybe your cells are being more active, and so the proteins will actually shift in their conformation. Hemoglobin, their physical conformation will actually begin to shift, and it'll start releasing more oxygen so that your cells will have more oxygen and be able to produce more energy, which is what you want if you've been more active. However, if your blood was become very basic, very alkaline, then your hemoglobin would actually shift in a type of conformation where it would be reluctant to release oxygen. Now think about that. Think about what would happen if your hemoglobin were releasing less oxygen to your body cells. Do you think that would actually be a good thing? No, it would not. Your cells not having oxygen would cause them to start to occur an oxygen debt, which would be bad overall. So just making something basic doesn't necessarily make it beautiful and good. Besides, a lot of the things that you love eating and drinking are actually acidic and not basic, like milk. Milk is not basic. Milk is actually slightly acidic. It's definitely below 7. Wine, cheese, lots of stuff that you use as extras that you put on your food, your salads and whatnot, those things are actually acidic. They're not basic. So you got to be careful with trying to lump something into one area and just saying one is bad, the other is good. That's not how that works. One last thing, I just thought about something. Kidneys. Your kidneys help to regulate pH in blood. And one of the ways that it does that is when blood arrives at the kidneys, the cells are able to tell and detect whether the pH is too low or too high. So if the pH is too low, that means it's acidic, and the kidneys will actually make sure to secrete and throw away more hydrogen ions in the urine. If the pH is too high, then it will actually reabsorb hydrogen ions to bring the pH down, because it's trying to balance pH. So essentially, the kidneys are just saying, yo, if it's too acidic, we're going to throw away acidic things and keep basic things. If the blood is too basic, then we will keep some acidic things and throw away some basic things. That's it. It's just trying to balance it out, keep everything happy. I think that's about it that I've got for that. I will hit up another video for our next chapter in just a moment. Talk to you soon. Peace.